So in this video, I just want to talk about, in simple harmonic motion, the maximum velocity or maximum speed and the maximum acceleration, and how you can get that in two different ways quite easily. So let's look at this first series of equations where you start off with your typical displacement equation for simple harmonic motion, differentiate it to get your velocity equation, and differentiate again to get your acceleration equation. What we consider here is that sine goes in between -1 and 1. That's what the sine graph does. So whatever this is, right, if you times it by 1, this will get down to its minimum because it's negative. And if you times this by -1, you'll get up to its largest value. So it doesn't matter what's going on inside that, right? NA would be the greatest speed. NA would be the maximum speed. And here, if you look at the acceleration, you have the same situation happening because cos goes in between 1 and -1. So when this is at -1, because that's negative, this whole expression will be at its largest. So the largest you'll get here is n squared a for the acceleration. So I'll just write that down. I'll just write down what I've found that the maximum is here. I reckon the maximum is NA for the velocity, and I reckon that the maximum is n squared a for the acceleration. Just take the absolute value as well if you want to. Now, we also have these two equations. V squared equals n squared a squared minus x squared, and x double dot, acceleration, is minus n squared x. I mean, this is the definition of simple harmonic motion. But these two equations, instead of relating the displacement, velocity, and acceleration to time parameter, they're relating it to the displacement, velocity, and acceleration in terms of the displacement, but you can still get the maximums out of it. For example, the maximum velocity we know happens as the particle is traveling through the center of the motion, because that's simple harmonic motion. It's fastest at the center. So you can put x is 0 to find the maximum velocity. If you put x is 0 and you cover that up, because it's 0, you get v squared equals n squared a squared. V squared equals n squared a squared, which means square root that and you get NA. Same with here. The maximum will be out at the amplitude. Maximum acceleration will be out. Now it'll be at the negative amplitude because direction has an effect, or you can take absolute value and just pick any amplitude. But it's out at the furthest end of its motion is the maximum acceleration. So if the amplitude is a, then you might put minus a in there, and then you'll get n squared a, which is here. So you can get the maximum velocity and the maximum acceleration just by looking at these equations here.